Hey guys, welcome to episode 3 of Object Series. This episode is on ball manipulation. Now in this year's FLL game, there's actually no ball mission to speak of. It actually doesn't occur anywhere on the field. So let's just talk about it as a hypothetical with no particular mission in mind. So as I stated, this one is to be able to extract, manipulate, and place a sphere where you want it on the field. So the first one is probably the most obvious one, and it's a closed funnel. And so the closed funnel is very, very simple. All it is just a funnel. You make it out of two straight pieces and two L brackets to kind of create, two L's, two obtuse L's that join together that can catch all the balls that come your way. They would fit in there like that, and they would all funnel together. If I could manipulate the shape, they would all funnel together in the back, and then you can move the entire assembly where you want it along the field and dump it any particular place you wanted. But that's very simple, and it's difficult to control the balls. You don't have really a way of closing the balls in, keeping them inside, and you don't really have a way of shooting them out besides running forward really fast and then going backwards, which wastes time and is very hard to do autonomously, which all of FLL missions have to be done. So again, this is the simplest one. It's called a closed funnel. You make it with make it with two straight brackets and two L brackets. But now let's get into something a little more interesting, a powered roller. So maybe you'll be able to tell from my drawing, but basically it's a long axle located right here. And as you can see, it runs along the length of this, connected at one point by just a straight piece that has holes in it that can hold the axle, and on the other side a motor. And so we haven't really talked about powered electronics yet, and I can cover more of that in my programming videos, but today we're just going to stick to the mechanical aspects. So ignore the programming. The motor would pretty much go right here, and if you stick the axle right in this part, it'll spin, it'll rotate wheels, and these wheels can actually pick up balls, and if you rotate them forwards as the balls touch it, they'll actually get sucked up by the wheels and shot inside. And so slowly, as you encounter balls and as the balls touch your wheels, they'll get sucked inside by the force of the rotating wheels, which is really, really cool. And so that's a really easy way to keep spheres inside, because as the rollers roll forward, they can't escape. If they go back and touch the wheel, they'll just be forced back inside. If they go up and touch, they'll be forced back inside because these wheels are rotating. And so that's a really, really simple way to do it. It's one of the simplest powered mechanical ways to do it. It does require programming, which is annoying, but that's FTC for you. And this requires anywhere from 1 to as many wheels as you can possibly fit on an axle. It requires one axle, which is denoted by this. Usually that denotes a straight piece, but for clarification, that is now an axle. Those are the kind of X-shaped long pieces that fit into the motors. And then obviously it requires one straight piece, or even a curved piece, but in this case it's a straight piece. All it has to do is be able to hold the axle in place. And then a rotor. And so this is more of a way of just capturing balls and then spitting them back out. And so a rotor kind of works the same way as a wheel, except it's a giant kind of spinning fan. And the balls go inside like this and drawn around this rotor. So the balls will enter in this way, and they will be pushed alongside a wall that feeds into your robot. So the balls will enter up here. The rotor will spin this way, which kind of seems strange, and I'll explain that later why it's spinning that way, but accept it for now. The balls will be pushed against these arms, located right here. They will be pushed against these arms, and as the arm rotates, just imagine that this is being pushed by this arm, as the arm rotates, it'll push it, and eventually it'll reach here, this solid piece right here. And so as it reaches this solid piece right here, as it's rotating this way, when it hits this solid piece right here, it'll actually get shoved out by the curve of the arm. And so see how this arm is curved? It's very important that this arm is curved, because then as the forearms rotate, it will squeeze the ball against this other curved surface, pushing it out, popping it out like this. And you can see how they'd be very effective. So as these balls rotate, through, they hit this wall and get forced out. Another one, as it rotates through, gets forced out. Brilliant way of getting balls in, not so brilliant way of getting balls out. For something like that, you would probably need a rotor or maybe a powered funnel that can push it forward. Like this one is actually attached to some sort of bumper motor, and it shoots them forward like that. What you want. Mechanics is about being creative. But anyway, these are just some ideas that I thought of. There are so many ways to manipulate spheres. While they may not be the nicest shape, there's so many ways to get them inside. These are just 3 that I thought of. The rest is up to you. Keep watching and keep creating.